Hello and welcome. I'm Tyler Fairchild, and today I'm going to be talking to you about what's called RAG. So, what is RAG? What does RAG stand for? What does it do? How does it provide benefit to your team? RAG stands for Retrieval-Augmented Generation. And I don't want us to get this too complicated, but I want us to kind of use our train of thought to pertain to our job, as it'll help us with creating our scenario, example, etc. So let's say you're at work and you are part of a customer service team. You're on a call with a client, and the question to you is complicated. You know it's in the back of your head. You know your team has reviewed this information. It's been very well documented, and for the life of you, you just cannot come up with what the answer is to the question from the client. Trying to remain professional and constant from team to team, from individual to individual, the standard is that the answer should be the same, no matter who the representative is from your company. Right? Now, let's say we'll put ourselves in a new perspective. Let's say that scenario happens over again, but you're given a chat box. Think ChatGPT, but don't think the flexibility quite of ChatGPT. Right? We need restrictions. So let's say that question is asked to you. It's fairly difficult, right? And maybe something more legal that your team has dealt with in the past, and you can't remember it. It happens all the time, every day. Right? Let's say you put it in the chatbot of yours. Your chatbot responds back to you, giving you a outline exactly what you need to say back, exactly how it was handled last time, any additional legal information that you need to make sure to say to your client at the time, right? Well, that's kind of going to help lay our groundwork for what we're talking about right now. So, retrieval-augmented generation. Again, I want us to think of ChatGPT. I want us to think of a generative model, a LLM, that is geared specifically towards your level of documentation. So your team has endless documentation. Maybe this is on Confluence. Maybe this is all in OneNote, right? And this information has then been taken. It's been stored into, for a case with maybe Amazon, you're using S3. Maybe with Azure, you're using blob storage. And then it has been what we're going to call chunked, right? And then it's been embedded. So it's then gone from chunked to then embedded vectors. And then with those embedded vectors, it's then been stored into an embedded vector database, right? Where an index is able to scan through quickly to find the most relevant towards the question, the most relevant embedded vectors towards the question that's being asked, right? So that's more so how we're going to think of this with RAG, right? So pretend you're giving your LLM a brain that has your job, right? That has your documentation that your team is supposed to use. Now think of this from a broader scope as well, where maybe there's a multitude of teams for your company. Maybe there's a more of a database administration team, maybe more of a client-facing team, maybe more of a sales team. Everybody has their own level of documentation. And you need your LLM to think not just from the perspective of answer the question, but you need your LLM to think from the perspective of a sales representative for your company. You need your LLM to think from the perspective of maybe your database administration team, maybe even a manager for the database administration team, right? So what if we were to be able to pass our role as a think tank into our LLM, telling our LLM to only think from this perspective? Well, that's what RAG gives us the ability to do. Right? So with that said, I built a process flow, a RAG architecture in Azure, and that's what we're going to go over here right now. So based off what I've built in Azure, I have PDFs that are being stored into blob storage. They're then being chunked with an Azure function. The chunks are being stored into blob storage one layer farther. The chunks are then being embedded into vectors. The vector embeddings are then being stored again into blob storage. Our next phase is that these embedded vectors are then imported into Azure AI Search, where a vector index is created. So Azure AI Search, the name initially, I'm going to be honest, threw me for a loop, and I thought of it in a different perspective. The best way I'm going to think of this right now is as a vector database for my RAG architecture, because it has the ability to do that, right? Then it pertains to my scenario right now. Now, as I learn more, that name probably will make more sense, but for my learning, that's how I'm going to think about this, right? Now, this Azure AI Search piece is only one small tunnel of our overall RAG user experience, right? So let's get into the user experience, what takes place for the user. So pretend you're a user, again, you're sitting at your desk, you're a customer service representative, you're on a call with a client, the question comes up, you submit your question to your LLM or to your chat box, right? Your chat box then takes your question and it converts it into a vector embedding. For my case, I used the model from Azure Foundry, text embedding -3 -small. Your embedding is then passed into your Azure AI Search, and you are trying to find the top nearest neighbor, so K nearest neighbor. If you've gone to school for data science, data analytics, you know about KNN, right? You're trying to find maybe the closest 5 embeddings that pertain towards that question. Now, if you find the closest 5 that pertain towards that question, you're going to be able to give a response, right? So then these chunks that have been returned, these embeddings that have been returned from your Azure AI Search resource, is then passed to your next stage. This is where it gets flexible, and I want to come back to this. We'll be back. No worries. This phase is then passed to your actual LLM model. So here I've got my GPT 4.1 mini. This model from Azure Foundry is able to do a chat, it's able to do a response, so you're able to communicate with it. Right? So this GPT 4.1 mini takes what was found in your Azure AI Search, creates it into a response that can be fed back into back to the user. Right? It creates a response, a generated answer based off of what was found in your Azure AI Search. Now, with that said, I mentioned about how we're going to come back here. I said a moment ago, whenever I was giving my example, how maybe you work on a database administration team, or maybe you work under a sales group. Well, this is where our limitations are placed. Pretty cool. So our Azure AI Search finds our K nearest neighbor chunks. It then passes maybe this group of 5 chunks back to your limitations, is what we'll call this stage for right now. Your limitations. Our limitations tells our GPT, our LLM model, that you need to respond in this manner. To take this kind of into context, maybe give a little deeper insight there, let's pull up what I mean. So in this overall pipeline, where we are doing this is, here we go. So we're telling our system, you are a helpful assistant that answers only using the provided sources. If the answer is not contained in the sources, say you don't have enough information. Always include citations in the format of source number. Then further instructions, we're going to give the sources. We're then going to give the instructions of answer using only the sources, cite every claim with source number, and then if the sources do not contain the answer, we need to say that clearly. So we do not need our LLM to hallucinate or make up a response because it can't find it. Right? So that's what's taking place here. We're giving grounded restrictions to our LLM. We don't need it to tell us to maybe tell the client to stand on their head when they just need to send us more data. Right? broad example, but to be a little goofy with it, right? So that's overall how this works, right? Our user submits a question to the query, and we call that a query. Our question then gets embedded into a vector, and then our vector gets passed to our Azure AI search or our vector database, and then it returns the X amount of closest chunks, right? Whatever we tell it that we want it to return with. Then it passes through to our limitations. Our limitations combined with our LLM model, or our GPT 4.1 mini for this instance, combines to create a generated final answer to the user. The user then receives this answer. So for my instance, what I have and what I've placed into Azure is a series of PDFs. These PDFs tell clients how to build a file that pertains towards a company and what these files need to contain, right? How these files should be constructed, etc. So let's put myself in the client's shoes and say that I am a client who needs to send some data over to this company, and we need to know maybe what are the what is the point of the LOA file that they need to send us, or what is the point of a particular file type that they need to send us. And I want to know, give me back a few reasons for sending this file. So I want to say, give me a bulleted response for the LOA file. I want to learn about it. I want to learn about this file. So we're passing that towards, again, to our RAG system, or our RAG chat box. For right now, this is where this is how I've got this set up. I don't have it set up to the fullest extent. We're going to call it a proof of concept or a MVP, a minimum viable product, and this gets us there, right? We're just communicating to directly with our Python script right now. So you can see, I told it to do that, and it immediately sent it back with an answer, as well as I got some source citations. So it says the LOA, leave of absence, is used for importing data related to special unpaid leave of absence for employees into health compliance. It specifically handles special unpaid leaves such as FMLA, USERA, jury duty, or other mapped special unpaid leave types, and so forth. And you can see I got a fairly detailed answer to my question, right? And so with that being said, this is the whole concept of RAG, made, what I would say is made simple. Again, trying to put myself in a client's shoes. I need an answer, and I don't need somebody to give me an answer if I don't know. Let me get back to you on that. I need an answer today, right? And so with that said, this representative that I communicate with, or my account services individual, could give me the answer immediately rather than later after they get with their boss or their lead, right? But this cuts down immensely. So the more your team learns, the more should be documented. The more that gets documented, the smarter your RAG architecture becomes, right? Now, of course, there's pipelines in between where you say, okay, I want a pipeline that sends data, sends new PDFs into my blob storage. I want my I want my blob storage to have a listening event that causes an Azure function to take place. That Azure function is going to cause the chunking to get created. That chunking, as soon as it's finished up, will then create the vector embeddings. As soon as those vector embeddings are in place and there's new vectors within our storage, or new files within our vector embedding storage, then we then want that vector embedding storage to be imported into our Azure AI vector database that we talked about earlier, right? Overall, the whole RAG application that I just showed can be wrapped as one serverless API function within Azure, and this would be just one API. So you've got a user interface that looks more like a chat box, and the engine, the brain of that chat box is just an API to your Azure function, right? And that's it. Kept it simple and light. And I hope this applies to you, and I hope your team is able to become better. And I hope you're able to be the solution today. Thank you.